Welcome to the solution for the database design challenge. Let's go ahead and get started right away. So let's go to File, New Project. And we'll come down here to Other Languages and select SQL Server. And we're going to select the SQL Server Database project. And let's call this Christmas List DB. And we'll call this project the Christmas List Solution. Sounds about right. And once this gets created, we'll have our kind of blank database project. There's nothing in it yet. We're going to create that right away. So the first thing we'll do is we'll create our DBO folder. And then inside here, we'll say we want a tables folder. We know we want one for stored procedures and one for views. So views and one last one for stored procedures. That's good enough to get started. Let's go ahead and design our first table. Now, normally, if I was going to do this for a real project, and this really is a real project, it's a test, but what I'd do is I would get a piece of paper and I'd draw out these different tables and the relationships. But here I'm going to just show you the kind of the end result of that planning process. Because the planning process really should be done on paper, not in the actual database itself, because it's much easier to change paper than it is to change your code. You also spend less time creating a table on paper versus in code. So let's call this table people. Now I could call this friend or I could call this family, but the reality is it's kind of both. It's both friends and family. So there's not really a common denominator there except for people. They're all people. So I'm just going to call it people and we'll call it good. Or let's even call it the person table. That way it's singular. And then here I'll make this an identity. And that just makes it auto increment. So it starts at 1 and it's going to count up. Now I'll leave it as ID. We'll say first name. And let's just do varchar. It's up to you if you want to do nvarchar or not, or varchar. It depends on whether or not you want to accept the Unicode character set. So it's up to you. I'm going to say no in this table because my friends don't have Unicode characters in their names. Last name. You'd have to associate it with a relationship. That way you could say, Tim Corey is my friend, and this is the amount I'm going to spend on him. Whereas my wife might say, Tim Corey is my husband, and this is the amount I'm going to spend on him. So same person, different budget amounts depending on the person using the database. But in this case, it's just for one person. Therefore, I can put budget amount here. And it's okay not to develop a database that is massive in scope when you really just need it for one person. That's kind of the balance there, right? Because when you're talking about, thinking ahead and thinking about how this might be used, yeah, you can think of all these different possibilities. But if you start developing for all of them, pretty soon you run this really complicated thing when you just want a couple of tables. And so here I'm saying, you know what? I just want a couple of tables. I just want it for one person. So I'm going to build it that way and just know to have to make some changes if I do want to make this multi-user in the future. So budget amount sounds good. I hit save, and our first table, the person table, is done. Now I need an address table. So we'll call this address, and we'll make the ID an identity. And this is just easiest, typing identity down here. I could come up to my properties. I could select the row and go to properties, and then go to identity specification, set it to true, and make sure it's 1 and 1. But just typing identity here does that for me. Now here's the first place where we're going to kind of get hung up, and that is how we link the address to the person. So let's first start by creating all the information for the address, and then we'll wire the two together. So real quick stuff, street address, and I'll make it varchar or varchar. I go back and forth between varchar and varchar. I don't know. It's how you want to say it. Okay, city, state, and for state, I'm going to specify that it should be 2 characters. This is also a US-based address. So that's why you're seeing some of these things that maybe you don't have in your locale, or maybe they're called something different. So, but in the US, we have a zip code that is a 5+4. So you can have just a 5-digit zip code, or if you want to be more specific, you can get the 5+4, which is 9 characters plus a dash, therefore 10 characters long. State is just 2 characters long, and address and city. So there we go. So that's an address, but now you got to think through, how do we link address to person? We could put in here the person ID that this is associated with, but then we have the problem of, what if 2 people live at the same address? My wife and I live at the same house. Therefore, we'd have the same address duplicated. That's not ideal. The other way of going about it, and that's the way we're going to do it, is if we go into the person table and we say address ID, then we can link in the address to a specific person. Therefore, my wife and I can have the same address linked in. Now, that is fine as long as you only want one address, which we do, because I'm only sending you Christmas cards to one location. I'm only mailing your packages to one location. I don't really care about the fact that you have a lake house in Geneva. I just care about your permanent residence, or the residence where you'll be for Christmas. So that might even be a different location, might be a hotel. All I care about is what's the address where I'm going to send stuff to. So that's, and actually going to allow nulls here too. Because what if I don't have your address yet? I don't want to stop getting presents until I know your address. I want to still be able to buy you presents. So that's okay as long as we have that one-to-one relationship. And this way, address becomes the primary. That way, you can have multiple people with the same address. But what you can't have is multiple addresses for one person. In that case, what you need to do is create a third table that kind of links the two together. But in this case, we don't need to be that complex. We've now linked address and person, and we're good to go. The last table we need should be the items that we've purchased for a given person. So tables, and this table is going to be called purchase. That's the purchase table. Again, we'll make this an identity. And now what we can do is list the information that's important to a purchase. Well, the first thing is a description. So actually, I was going to do it down here. I'll do it up here. It's just a little faster up here, I find, but it's up to you which way you want to go. So in this case, I'm going to say that we're going to have a item name, and we'll varchar 50. And I don't think we need a description. I think that we know what we're purchasing, and that can be something a little more descriptive anyways. 50 characters is quite a bit to describe something. And then we need a price. And that again is the money type. And we're not going to default it. We're going to leave it as is, but it has to be filled in because we need to know how much something's going to cost us because that goes against the budget. And the last thing we need to do is we need to identify who this is for. So we're going to say person ID. Let's call it something that says person ID. Because person ID is impersonal and doesn't really describe what the field is holding. It describes the fact that it's a person ID, but not why it's a person ID. What does person ID represent? So let's call this purchased for ID. So we've now purchased something and we're saying this is who we purchased it for. In this case, we're going to say, maybe my ID. So my wife puts in my ID here and saying that she purchased something for me. All right, so now we have our tables, and really that meets all of the goals or all the statements in the goal for the main goal. That's our 3 tables. That's how you link together. We thought through, linking address to person, not person to address. Actually, person to address, not address to person. And how to bring in our purchases and how to link those into the person and so on. So that's all we have to do for the basic goal. But let's move on to the bonus challenge, which we've already started with the budget amount for each person. We have that in our person table. But now let's create a view that identifies who we have left to shop for and how much left we have to spend. Now, I often find, I'm going to design a view, but I think what we're going to do is we're going to create the tables in a database, and we're going to populate them with a couple of records. That way we can see and make sure that what we think is happening, it really is happening. Just like with writing C# code itself, when I write database code, I really want to test it to make sure that I am thinking things through, and I've also tested all those edge cases. Okay, so let's create our view first, and then we'll create an actual database. So add a view. Let's call this view people left to purchase for. All right, so there's our view. Create view dbo.people left to purchase for as, and then just select star from. So that's our view. Let's go ahead and change this to select star from. And this is where you start asking the question, well, how do you want this view to look? So let's start the basics by putting in the person. So we'll say dbo.person. We'll call this P. I would like to shortcut my table names just to make my queries smaller and less messy. So we're going to say we want the P dot first name, P dot last name. And for now, we're going to say is budget amount. Okay, but that's not right yet because of the fact that we have, in theory, we've had some purchases. So we got to find a way to bring in the list of all of our purchases based upon the person. So let's do this. I'm going to say left join. Now, left join means I'm going to take everything from person and only the records that match from, in this case, my purchase table. So left join dbo.purchase. And the reason why is because there might be a case, and it's going to be at first, where I've not made purchases for a given person. I don't want to not see that person in my list because I haven't made a purchase for them yet. Just the opposite. And notice I have another P table name. So P won't work, but I can say PU or PUR. I think PUR is probably better. In this case, I'm going to change the PER to keep with the theme. So we're going to join on PER.ID equals PUR.purchased for ID. And I'm looking at this and I'm thinking that's probably not going to work the way I want it to. And the reason why is because what if I have 3 purchases for a person? That's going to link 3 times this record. And that's going to cause duplicates on the person side. That's not what I want. I want to actually group those purchases together into a sum. How much have I spent on this person? So not quite what I want yet. So I think what I'm going to do instead is create a subquery. So let's start here. We're going to open our parens up. Inside our parens, I'm going to say select. I always start off with star. That's just my convention, so I can get to, the IntelliSense. So let's start from purchase. And instead of star, I'm going to say, let's say that I'm going to, there's IntelliSense. And actually, I want, here, let's look at the purchase table. I wanted my short list of IntelliSense, and it's not giving it to me, but that's okay. I want the price. So how much I spent for something. And actually, I want a sum of the price. So now I'm going to get a sum of the price where, and let's say that I believe it is, let's go to purchase table, make sure, purchased for ID. There we go. Purchase for ID purchase for ID equals PER dot ID. Okay, so that should give us one record. If there is a record, we actually need to do a group by. Well, no, we don't, because we're doing just a sum. So let's leave it like that. So now we have a new record. This is going to go through and select a sum of all the prices in the purchase table where the purchase for ID matches the one out here. And actually, we do need to bring in the ID of the purchase. So we'll need to say group by the purchase for ID. This is why I run these queries against actual tables, because it takes a couple of laps through your brain to get these things right. So we're going to create a purchase for ID. We're going to say group by purchase for ID. That way it's going to group these together based upon the purchase ID. And actually, we don't even need to do the where clause. So there we go. Much better. So now we're going to group by a purchase for ID. So if my ID is 1 and I have 3 purchases, there need 3 that get grouped together. The sum of their price gets put out as total spent. And then it's going to be based upon my ID. So ID number 1, total spent is $25. because there was a $15 purchase and two $10 purchases. Or two $5 purchases, sorry. So select purchase for ID and the sum from this table, group by purchase for ID. And we'll say as PUR, that's the purchase table, where PER.ID equals PUR.purchased for ID. And it's not where, it's on. There we go. So now we have this left join where we're essentially creating, if you liken it to C# terms, we're creating an anonymous class. We're creating an anonymous table in this case, or anonymous view, where we're doing a select inside here, wrap it in parens, and then naming that as a table. So we're giving that the results of this select, a subquery, we're giving it a name, PUR, and then saying link these two based upon the ID matches in the purchase for ID. So now I have this new record, which I could put right here. I'm going to for now. PUR.total spent. So now I have a list of people, how much I budgeted for them, and how much I spent on them. Now the eventual goal is going to be to get a amount left to spend. So let's create that as well. I'm not going to take away these first two columns though, because I want to make sure that I can do the math as well and make sure the math lines up. So I'm going to say in parens, PER.budget amount minus PUR.total spent as amount left to spend. A little wordy for a column, but that's okay. So now I have this final column named as amount left to spend. That is the budget amount minus how much I've spent. That should give us an amount, even if it's negative. So if it's negative, that means I've gone over. That's okay. And I think eventually what we'll do is we probably want to filter this view by only people who have something left to spend. Okay, so if I've already spent all I need to on my wife, then my wife would drop off the list so that by the end, hopefully my list is empty, or this view is empty. So let's save this view. This view should be good enough for now. Let's save it. And now what we're going to do is I really want to create this database, because if this database, doesn't work the way I expect it to, or something's wrong here, I want to know now. So let's first bring up my SQL Server Object Explorer. And let's open up my local DB and open up my database. And there's nothing in there. Now let's go ahead and publish to that database. I'm going to pin that. Oops, I unpinned it. I'm going to pin that. There we go. And now what we'll do is I'm going to create a publish profile. So let's first create a folder for that. Publish profiles. And now we're going to publish this database just locally. So I'm going to say edit, browse, local DB. I hit OK. And my database name, let's call it Christmas List DB. Make sure I spelled it right. And the only thing left I'll do is save profile as. This is where I put in the publish profiles and hit save. And now let's publish that database. So this gives me my tables and my view once it's done. And now what I can do is refresh this list. See my database. I can go into my tables. I can right click on person and say, let's view data. Because view data also allows you to do something else, which is to fill in records. Budget amount. Now I'm filling it out as if I'm somebody else. Let's say I'm my wife. So this is going to be her list. Therefore, I'm in that list, and she's going to spend $100 on me. And then let's go with, 50 for my son. And 50 for my other son. Okay? And if you refresh this, we now see we have 3 records. I'm not worrying about address right now. I don't really care too much. But I know that Tim, John, and Chris are 1, 2, and 3 for their IDs. So now let's add a couple of purchases in here, just so we have something to start with. Actually, let's look at the view first. So let's view data on the view. And notice the view says total spent is null. And amount left to spend is also null, which doesn't sound right. Because it sounds like we should have something in there. So let's go back over, and since one last thing to point out here is if we look at the data again, we can see the null amount, and that's for the total spent. And that's why we have a problem. So you can't subtract null from an amount. Instead, what we need to do is we need to figure out how to change this over to be a 0. Let's go back over to our view, and here's where our problem lies. We have this subtraction right here, but we can't subtract a null. So we're going to use the coalesce. If I can spell it right. There we go, coalesce. What the coalesce does is it gives you your first non-null value back. So coalesce is going to say, okay, is this null? If it's not null, if total spent is not null, then go ahead and return that value. But if it is null, don't return null, return the next value. And you can do this multiple times. In this case, I have a fallback of 0. You've spent 0 on this person because there's no records for this person. Let's go ahead and save this. And now I'm going to publish again so that I have that updated view. And now if I right click and say view data, I should have a new view. And I do. Now my amount left to spend is 150 and 50. That's because even though this is a null column, and I left it as null here, but even though it's null, I've said coalesce so I can subtract 100 minus that 0, and now I get the 100 back. Let's see what happens when we start adding in purchases. So item name is, let's just say a watch. And let's say it's $15. My wife went all out, buy a watch for me. And it's for me, so it's ID number 1. And just to make life interesting, she also bought me gum for a whole $2. And it's also purchased for me. And she bought my son, John, a game for, $25. And that was ID number 2. She hasn't done any shopping for Chris yet. So that's it. Now I can go right click and say view data. And now you can see that the amount left to spend is $83 for me, $25 for John, and $50 for Chris. Because she spent $17 on me and $25 on John. Notice that the 17 is an aggregate or a sum of the two values we have here, which is 15 and 2. So now our view works correctly. Took a little bit, and it was a little tricky, but we got it to work, and it just required us to kind of think through how to group these things together in a way that makes sense and gives us the data points we need in the way we want. Now, there are other ways of doing this view, but I think this one's probably the most efficient. So that's our view. Now we can go ahead and move on to our stored procedures. So that's stored procedure to capture purchases. Let's right click on store procedures here and create that. So store procedure, let's call this store procedure capture purchase. And now we know we're going to have to pass in some parameters because this purchase table has a few records or a few entries. So to populate it, we have to have the item name, the price, and who we purchased it for. So let's actually match these up. So at item name, and that is a varchar 50. At price, and that's a money field. And then the other one is purchased for ID. I'm actually going to copy and paste that. And that's an int. I like matching these up word for word the same, unless we're going to change it for a reason. But this way, it's really easy to see what these match up to. And we don't accidentally match up an ID incorrectly. So if I just pass in person ID here, I might put it in the wrong spot. But with purchased for ID, that matches up to purchased for ID. In fact, if we do an insert statement here, which is what we're going to do, insert into dbo.purchaseTable, and we're going to say item name, price, and purchased for, the values become very simple. Item name, price, and purchased for. And that's it. So that's our insert statement. We're done. We don't have to do anything else. So let's go ahead and hit save on this. And we're going to publish that over to our database, which is really quick by this point. And now under our programmability, store procedures, we should see that one store procedure called capture purchase. If I say execute, it's going to ask me for the 3 values to pass in. So item name, price, and purchase for ID. So let's just create a purchase for my son Chris, who is ID number 3. So the price, let's just say it's $47.89, and the item name is Lego set, which actually it should be like so. And now we hit OK. And return 0, which just means it worked, it ran. That's ultimately telling us there. And now if we go to people left to purchase for and say view data, we only have $2.11 left to spend on Chris because of that purchase. So we're good there. So our store procedure works, our view works, our tables work, and we can start using this in our application, put a front end on it, and now we've got a tool for our Christmas purchases. So the bonus challenge had some tricky bits to it. The idea of how to get that view to work really well was difficult. It takes some thinking through and some going back to the drawing board a couple times to make sure we get it right. But the end result is a really powerful view that's easy to use, that you can just toss right in your application and make it work. Okay? Now, the one thing we didn't do that I kind of go back and forth on, do I want to do or not, is if we open this up, the one thing we haven't looked at is, do I want to limit to only positive non-zero amounts for amount left to spend? So if you cross over the threshold, do you want to drop off? And I think the answer here is yes, I kind of do. So let's do that. You can keep this clause off and not have it do it, but in this case, I'm going to. So where, and this is, we're going to do a copy this, and this is a little less efficient. So just note that's the case, and let's try to put it in up there, and that's interesting. So let's just start typing it out. Per dot budget amount minus coalesce per dot total spent and 0 is greater than 0. Okay? So what we're saying here is as long as your total is greater than 0. Again, this is less efficient as a query now, because of the fact that we're doing calculations in our where clause. It might be better to do another view or wrap this whole thing as a subquery, and then just say where the total spent or amount left to spend is greater than 0. It's up to you if you want to go that far, but this makes it so that it at least works for now, but we can make some tweaks to make it more efficient as we go down the road if we need to. So with that being the case, we can hit save on that, publish it over, and it shouldn't work any publish this again. I would still be on this list, but I'd have a negative value. So negative $67. Okay, so it's up to you if you want to see that negative amount or if you don't. I think it makes sense to not show it because these are the people left to purchase for. That's what the name says, and that's what it's for. And so therefore, you don't want to see me if you've done all the purchases for me already. Okay, so that's the one thing I'd probably add to my list. But otherwise, this is done. We've met all the goals and the bonus goals as well. So our challenge is complete. I hope that you got it. I hope you figured it out. I hope that maybe you learned something as well. Thanks for watching.